So in this problem, we need to determine the equation of a circle with the center lying on the line given by the equation 3x plus 4y equals to 7. And the circle passes through 2 points, 1, negative 2 and 4, negative 3. So let's try to understand the problem graphically first. Let us consider a circle having a center given by C. Then we have a line which is given by the equation 3x plus 4y equals to 7, and the line is such that it passes through the center of the circle. It's also given here that the circle passes through 2 points. So let's say the 2 points are A and B. So A has the coordinate given by 1, negative 2, and then we have the other point B which has the coordinate points 4, negative 3. Now our goal will be to find out the equation of a circle. Now, to find out the equation of a circle, we need two key information. One is the coordinate of the center and the second is the radius of the circle. So let us begin by doing a construction first. So we are going to join A and B to form the chord AB. Next, we are going to drop a perpendicular from point C on the chord AB, which is going to meet at the point E. Now here we have done the construction that CE is perpendicular to AB. Now we know for a fact that the perpendicular drawn from the center of a circle to any chord on the circle bisects it. So this would mean that E is the midpoint of the chord AB. Now since E is the midpoint of AB and we also have the information of A and B, we can easily find out the coordinate of E. To find out the coordinate of E, all we have to do is to sum up the x and the y coordinate of A and B and divide by 2. So to find out the x coordinate, we add 1 and 4 divided by 2. To find out the y coordinate, we add negative 2 with negative 3 and divide by 2. So this is going to give us 5 over 2, negative 5 over 2. So this is going to be the coordinate of E. The coordinate of point E is going to be positive 5 over 2, negative 5 over 2. Now, our next task will be to find out the equation of line CE. To find out the equation of line CE, we'll first need to find out its slope. Now, we cannot directly find out its slope, but we do have the information regarding A and B, so we can find out the slope of AB. The slope of line AB, so that's simply the ratio of the difference of the y coordinate to that of the difference of the x coordinate. So this will be equals to, we can either consider A to be x1, y1 and B to be x2, y2, such that we get negative 3 minus of negative 2 divided by 4 minus 1. So we get negative 3 plus 2 divided by 3, which is going to be equals to negative 1/3, meaning the slope of line AB is negative 3. So let's call it as M1. So M1 comes up to be negative 3. 1 over 3. And we'll define let's define the slope of CE, which is the perpendicular bisector, as M2. Now we know for a fact that whenever we have two lines that are perpendicular to each other, then the product of their slope is equals to negative 1. Now we already have the value of M1, so M2 will be negative 1 over M1, which gives us the value positive 3. So we have obtained the slope of line CE. Now we have one of the coordinate point for E and we have the slope, so we can use the 1 point slope form to find out the equation of line CE. So let's do that. So let's first specify the 1 point slope form. The 1 point slope form states that if we have a point, let's say x1, y1, that's the coordinate of that particular point. If a line passes through that particular point with a slope m, then the equation of the line is given by y minus y1 equals to m times x minus x1. Now in our case, we have the coordinate of point E. So point E, we found out its coordinate is 5 over 2, negative 5 over 2. And we have the line passing through it, which is CA, center C, and we have to join E. This is the perpendicular bisector of the line AB. We are interested in finding the equation of line CE. So let's do that. So equation of line CE, so that's going to be equals to, so we have y minus y1, so y1 will be negative 5 over 2, equals to the slope of line CE, that's positive 3, we have 3 times x minus x1, so x1 is 5 over 2. Let's further simplify it. We are going to get y plus 5 over 2 equals to 3 times x minus 5 over 2. Multiplying throughout with 2, we get 2y plus 5 equals to 3 times 2x minus 5. So we get 2y plus 5 equals to 6x minus 15. So we have 6x plus minus 2y, that's going to be equals to 20. So these are all multiples of 3, each of the terms. So we divide. So we have 3x minus y equals to 10. So this is the equation of line CE. Now that we have the equation of, let's go to a diagram, equation of line CE. We also have equation of the line that passes through the center. So if we solve this two equation, we're going to get the center point or the coordinate of the intersection point, which is going to give us the coordinate of the center of the circle. So let's use this. 3x plus 4y equals to 7. 3x plus 4y equals to 7. Let's label this as equation number 1. And we have 3x minus y equals to 10. We're going to label this as equation number 2. Let us subtract equation number 2 from equation number 1. This is going to help us eliminate the value of 3x. So we have 5y equals to negative 3. So y comes out to be negative 3 over 5. Now that we have the value of y, we can use either 1 or 2 to obtain the value of x. So let's use 1. So we have 3x plus 4 times negative 3 over 5 equals to 7. So that gives us 3x minus 12 over 5 equals to 7. So we get 3x equals to 12 over 5 plus 7. So 3x will be equals to, so 35 plus 12 is 47 divided by 5. So x will be equals to 47 divided by 15. So now we have the value of x as well as y, which is nothing but we have x comma y. This is the coordinate of point C, which is also the center of a circle. That's 47 over 15 comma negative 3 over 5. So we have the coordinate of the center and we have the 2 points A and B. So let's join point C and point A, and this is going to give us the radius of the circle. We can easily obtain the radius of the circle by using the distance formula. So we'll have to take the square root. Underneath the square root, we have to take the square of the difference of the x coordinate. So we take 47 over 15 minus 1. So that's the difference of the x coordinate. Then we'll have to square it and add it to the square of the difference of the y coordinate. So for the y coordinate, we have negative 3 over 5 minus of negative 2, so that becomes positive 2. So I'm leaving this as an exercise for you to try out. The value of the radius comes out to be equals to square root of 1465 divided by 225. So now we have the radius of the circle as well. Now that we finally have the radius of the circle as well as the coordinate of the center of the circle, we can find out the equation of the circle by using the standard form. So let's specify the standard form of the circle. So the standard form of a circle states that if we have a circle whose coordinate of the center is given by h comma k and a radius of r, then the equation x minus h whole squared plus y minus k whole squared equals to r squared gives us the standard equation of a circle. Now we have obtained the center. So our center, which is h comma k, so that came out to be positive 47 over 15 comma negative 3 over 5. So this immediately gives us the value of h. So h is 47 over 15 and the k value is negative 3 over 5. And we have also determined the value of the radius. The radius was square root of 1465 divided by 15. So I made a mistake here. So this is actually square root of 1465 over 225. That's the radius of the circle. Now finally, we have the standard equation of the circle will be x minus 47 over 15 whole squared plus y minus k, k being negative value. So we have positive 3 over 5 whole squared, and this is going to be equals to the square of the radius, which is 1465 divided by 225. So we have finally obtained the equation of a circle.